Hey there. So for the first lecture of this course, we're going to start in chapter R, which I guess means review or reference or something like that. The idea being that we're going to do some review of algebra topics before we get into calculus. So we're not going to do any calculus until we get to unit 2. The idea here is that we're going to refresh on algebra topics because a lot of times in a calculus class, the algebra is where the mistakes come from. So we're going to spend some time in chapter R and then also a little bit into chapter 1 and 2, which is a lot of algebra review. So what I have are the notes that are uploaded onto Canvas. I typed up those notes and I'm going to be using those for my lecture recordings. I invite you to download those notes and hopefully it helps you follow along. All right, so let's get started. All right, so section R1, polynomials. So algebra topics, but I'm going to go through at a little bit of a faster pace through these than if this was an algebra class, because a lot of this is stuff that you may have seen in the past. Okay, so for section R1, polynomials, basic terminology, let's just talk about polynomials. An expression of the form a times x to the power of n is called a term. A is the coefficient, x is the unknown called the variable, and n is a positive integer called an exponent. Polynomials show up all over the place in mathematics in numerous applications. Okay, terms having the same variable and same exponent are called like terms and be combined with addition and subtraction. A polynomial is a term or a finite sum of terms of the form, and don't let that scare you. That pretty much just means we've got an x to the power of n, that could be like 3x squared, for example, plus another coefficient with the variable to a different power, plus dot, dot, dot. And so this is just a general form of a polynomial, okay? The term with the largest exponent is called the leading term. Its coefficient is called the leading coefficient, and its exponent is called the degree of the polynomial. Okay, so just some terminology there. Polynomials can have multiple variables involved as long as the coefficients are real numbers. So in this class, we don't deal with imaginary numbers. Maybe you recall that I number, the square root of a negative. We don't deal with imaginary numbers in this class, okay? So the coefficients are real numbers and the exponents are positive integers. An integer just means a whole number. Okay, recall the order of operations. So the order of operations is simply an agreed upon centuries-old method for combining numbers or terms when various operations are involved. So maybe you've heard of that acronym PEMDAS that kind of helps us remember the order that you're supposed to perform these operations in. And so here's the breakdown. The P stands for parentheses. And so that means if you see parentheses, you need to calculate everything inside the parentheses first. Okay, then we move over to E, which is exponents, and you work out any exponents from left to right in the expression. The MD in PEMDAS is multiplication and division, and that has the same kind of a rank of which order you do it, as long as you just move from left to right, doing all the multiplication and division. And then the AS at the end is for addition and subtraction. And again, that has kind of the same rank in this order, and we just move from left to right. So let's do a quick example using the order of operations with some numbers here. So perform the following operations and simplify. So here we go. I'm going to go ahead and work this out. And I've seen these kinds of problems on like social media where like everybody's arguing about what the answer to this is. Maybe you've seen that kind of stuff in the past, but if you know the order of operations and you follow it very specifically, then you are guaranteed that you know what the answer to this thing is. Okay, so let's go very, very carefully with the order of operations. So starting with parentheses. So we do see that we've got parentheses right here. Okay, so that section has parentheses, and all that means is we have to do whatever's in there first. And inside the parentheses, it could be a whole other world that has to have the order of operations as well. So inside there, we need to apply the order of operations again. Okay, so in there, let's start over. Are there any parentheses inside the parentheses? No. Okay, so we're done with that one. Okay, inside the parentheses, are there any exponents? No. Okay, are there any multiplication and division? Yes. Okay, so we have 2 times 3. Okay, it's very tempting when you're looking at this, and this is why people argue about these. 8 minus 2 is very tempting to want to do that right now. But based on the order of operations, we have to do the 2 times 3 first. Okay, so I'm going to write down everything as it sits, x plus 5 times 8 minus, and now I'm going to do the 2 times 3 for a 6. Okay, I'm going to write down everything else just the way that it was, because that's the first thing that I did. Okay, now continuing on the inside, now we can do the subtraction on the inside of the parentheses, and so we have 4 plus 5 times, now we can do 8 minus 6 is 2, plus 3 to the third power divided by 9 times 2. Okay, so I still have those parentheses right there for the 2, but they're kind of just like a placeholder. There's nothing left to do inside them. So we can move on, no more parentheses in the expression, so we can move on to exponents. Okay, so step 2, we do have exponents. So I'm going to write everything just the way that it is. 4 plus 5, and instead of parentheses, I'll write this as like 5 times 2, just to emphasize that there's no more parentheses involved. 3 to the third power. Now be careful, that's not 3 times 3. It's tempting to put 9. Remember that 3 to the power of 3, exponents mean how many times you multiply by itself. So this means 3 times itself 3 times. So 3 times 3 times 3 is 27. Okay, so now we're done with exponents. Now we move down to the next list, multiplication and division. And for this one, we just go left to right. Okay, so for multiplication and division, let's see, we'll leave that 4 alone, plus, okay, 5 times 2, so we have to do that one, that's 10. Okay, plus, here we have 27 divided by 9 times 2. So we're just going to go left to right, following the order of operations. So 27 divided by 9, we can do that one first as 3, and then I'll write down that times 2, running out of space, so I'll go over here. Okay, now continuing with left to right on the multiplication and division, we leave it as 4 plus 10 plus, and now that 3 times 2 is 6. Okay, and then finally we have addition. We can just go left to right. So 4 plus 10 is 14. And then there's that plus 6, and then finally the 14 plus 6, and we get a final answer of 20. And as long as we follow the order of operations very specifically, we know that that is the correct answer. Okay, and yeah, this order of operations, like I said, it's just by convention. It's just agreed upon centuries ago that this is how we do it. And this is to make sure that if we're doing mathematics in the United States, it's going to match up with the mathematics that's done in Germany or China or anywhere else. It's just agreed upon in mathematics. Okay? So some properties of real numbers that are really important, especially when we're dealing with polynomials, because polynomials behave a lot like numbers in the sense that you can add them, subtract them, multiply them, divide them, all that kind of stuff. So for any real numbers, A, B, and C, these properties might seem really, really obvious to you, but they do have names. So for number 1 here, A plus B equals B plus A, or A times B equals B times A, that's the commutative property. And that just means that with addition and multiplication, the order doesn't matter. You can add in either order, and you can multiply in either order. Okay, so I'll ask the philosophical question, does that still apply for subtraction? Okay, think about that one. Okay, for number 2, A plus B grouped in parentheses plus C, that's the same as A plus, and then grouping the B plus C in parentheses, and similar groupings with multiplication. Okay, so that's the associative property of addition and multiplication. So you can pretty much associate, meaning like group however you want with addition and multiplication. Again, do you think that that still works with subtraction or division? Okay, so think about that. I'm purposefully writing these using addition and multiplication. Okay, and then the distributive property, if you have A times parentheses B plus C, recall that that just means that you can distribute and that A would multiply onto both of those pieces in there. Okay? So on this next page, we're just going to go through and do some operations with polynomials. I think I'm going to go ahead and make a separate video to do this page. I want to make sure that as I'm recording videos all through the semester, I don't want them to get extremely long. I'd like to break them up into like 10 or 15-minute videos or something like that. So stick around and I'll finish off section R1.